Like I said, my name is Kumsal Obuz. Don't worry about if you have hard time pronouncing my name. I've heard a lot of versions of it. Feel free. I won't be offended. A bit of about me. I did web development for more than 15 years, both in Turkey and Canada. So over time, I got really tired of doing web development, and for me, it boiled down to taking user information and submitting to databases. It didn't matter if this was Facebook or Twitter, because I kind of think the whole web experience is basically data submission, which became boring after 15 years. So I thought solving game development problems might be much more interesting. And after I found myself unemployed in July 2020, I decided that it was actually time to start my company. So I created Godot Games. I decided to release a game to see how the whole self-publishing would work. Since then, I've been working on a farming simulation game called Urban Farmer. The project is quite big, and it needed funding. So in the meantime, I thought I would also do some other stuff on the side. So last September, I was approached by Pack Publishing, and they asked me to write a game development book, which is the topic of tonight's presentation. By the way, I also organized Godot Toronto. If you guys are interested in learning about Godot, the time zone is a bit weird, maybe, because we meet at 7, usually the first Thursday of every month. So it might be a little bit late for your time zone. But sometimes when we have presentations, we try to record them too, and they might be available. So that's another avenue for you to learn Godot. Also, you will probably find two types of people, either saying Godot or Godot, or different versions of this. I think officially the creators of the software, I think they settled on Godot, but you will still find a lot of people say Godot. That's also perfectly fine too. The controversy there. So tonight's agenda, I'm gonna cover a few chapters of my book. I'll try to keep it relevant to the group. So assuming most people here are already okay or familiar with creating models and textures and the 3D workflow with Blender. So I'm gonna start in chapter 6. So now that we have models, well, how do we reconcile all these models with the game engine? And so this involves making the models ready and then exporting them. Then of course we have to look at the importing process. And once the assets are important, we are going to create usable game objects. That's one thing that is sort of different between Blender and Godot. In Blender, your work is mostly static. And I'm not talking about animation. You could animate your models in Blender, but they don't really interact with there is no world, no sort of game mechanics in that sense. So game engine makes your models interact with each other in a sense. So we'll look at that. And to make things looking more appealing, we'll investigate how to adjust lights and environment. So let's say you created models and you got to a certain point that you feel your models are ready, but like ready in the sense that they look beautiful. The game engine may have a different opinion about the readiness level. So there are usually 4 things you have to be careful about. So this is not necessarily an order of importance, but let's just go in this order. So you may end up with what is called in the industry an angon, meaning you will have the number of vertices making a face, so that like you will have more than 4 vertices making a face. And I think for this, I'll go and show some files to investigate. Let's see. This is in chapter 6, I said. Okay. This is when I am showing my lack of familiarity with Zoom. So, okay, angons, there you go. So let's open this Blender file. So angon is basically a generic name for any type of geometry that has more than 4 vertices. Here we have a pentagon, but this could be any kind of known angon. So the problem here is, if you look at this statistics part, there is only one face that is the result of 5 vertices. Here's where this could be problematic. Of course, this is an isolated case. It looks such a simple geometry, but if you put enough of these vertices, and if you have a game character, and most game characters will have body parts that are bending, you will have walking cycles, that kind of thing. So when the vertices and the geometry is bending around certain points, this sort of face will be processed by your GPU, your graphics card, and the GPU will try to break this face down so that it actually has triangles. So here's a manual way of creating triangles. So like this is the simplest way to create proper faces out of this pentagon. Now we have a triangle and a quad. So this is an accepted geometry. Sometimes your graphics card may took the liberty to divide it this way. This is acceptable too, but if the remaining vertices and the way these, let's say, edges are flowing, it may create unwanted results. So if your model is going to be used in animations, you got to be careful about not leaving any angons. So there's a bit of cleaning up process. If you're not going to animate your model, you could get away with leaving angons. So then you could have pentagons, hexagons, and any kind of like combination. It may still look horrible, but it will pass the test of the GPU and the game engine. So this is one thing you got to keep in mind. So here you see the other combinations, and this could quickly turn into a math problem. Like how many times can you divide a pentagon to create maybe 2 or 3 faces, that sort of thing. Another common thing that you will deal with is setting origin points. I think this is something most Blender users come across when they are animating, because when you want to animate something, you will want to rotate or scale your objects around an origin point, or sometimes I hear it's a pivot. So this is especially important for game engines, because all the physics and calculations are done according to this point. So I'll show an example. Origins. So these 2 barrels, besides their color, they look the same, and they have the same proportion, but I'm going to select both and sort of move the camera this way. This yellow one, the origin is at the bottom, and this one is in the, let's say, center of gravity. It's volume-wise right in the middle. So when rotation is going to be applied to this red barrel, it's going to turn around that origin. So if you do this, it's going to rotate around that. But here, this is sort of like, connecting with ground. You may actually take this a step further and say, well, what if I want to apply force from the right side and this barrel is going to tilt and then be knocked over this way? Then you will have to move your pivot point here so you can apply the proper transformation. That's why the decision on this is, there's no golden rule, kind of is, it depends on the situation. But it's something that you have to keep in mind. Because either one will work. The angles might cause a problem, but this is not exactly a problem. This is more of a kind of like whether you like it or not, or if it's the right application. It looks more natural to the eye. We have another case here with the rotation and scale. So like rotation kind of matters here with the origin points, but this is a different kind of rotation problem here. And I'm going to show a different file for that. And so again, besides colors, these cubes look the same. I'm going to select the green one. And I'm just going to let you read the properties here. Maybe more specifically dimensions, 4 meters on each axis. And then the red one is also 4 meters too. Indeed, to our eyes, they both look the same size. However, the red one is 4 meters as a result of scaled up like by 2. So it's as if this was 2 meters on each side, but was scaled up to get to 4 meters. The other one is at its original scale, but it's the same dimensions. So this is a big difference when it is imported into game engines. This is not exactly a Godot engine problem. Most engines are sensitive to this sort of behavior, or this sort of value, different values being different. And here we have another problematic case. Visually, they kind of look the same, but this one has been rotated 90 degrees around its z-axis. So a typical problem of or outcome of this issue might be if you are building a human character. So you will want the character's face to be aligned with a certain axis. Let's say it's Y or X direction. It may not matter to you because, like, well, what difference does it make if it's facing Y or X? And again, it may still not matter which way you set it up, but you have to make sure that this value is zeroed in. So luckily, there's an easy fix for that. You press Ctrl A and you'll choose rotation and scale. This value will not change. And well, this looks the same. It's not actually rotating a different way. But now these two cubes are considered the same. So the red one is actually safe to be imported into Godot. I'm going to close a few screens here. Last thing in our list of making models ready is the export format. I don't know if there are people in the group who have experience with Unity. Usually the format that Unity people prefer is FBX file format. In Godot, a different file format, GLTF, is preferred. Maybe I'll actually open one of these again. Let's pretend, actually, the other one is probably better. This one. Let's pretend we want to export one of these guys. So yellow barrel is selected. And here's your export option, GLTF. So this is where you may sort of get lost a bit. That's why I'll do my best to explain what's going on. So again, for the sake of brevity, I cannot explain every single thing here tonight. That's why there's a book and you can read more about it. But essentially, if you have a lot of objects in your scene, this option may matter so that you are not exporting camera and light to Godot. This is something you'll never touch, most likely. But why that might be, like, if you don't know anything about it, it might be tempting to turn it off. In the z-axis in Blender is the height axis, let's say, but in Godot, plus y is the up axis. So this is making sure that once it's imported into Godot, the proper orientation will be maintained. You'll never expand this and bother with that. Most likely this part, as I said, is needed. Geometry and animation. If your file, if your model doesn't have any animation applied, selecting this will not do anything extra. So this is also something that maybe you won't worry about most of the time. If you do have animation, then you might be a bit more careful about what you are selecting here. The more advanced animation case you have, you can customize your export options here. Most of the time, this geometry part is important. And I'm going to talk about this in more detail. I might be actually bleeding into the next slide. Let me check. Yeah, we'll get to that part. So when you're exporting your models, you can also export the materials. These materials are the materials that you are defining here. This is not a limitation between Blender and Godot. Universally, there is no standard pipeline between 3D software and game engines, meaning the material that you will be creating in Maya, Blender, or any other 3D authoring application, you cannot 100% transfer to any game engine. There is no such thing in the industry as an exchange format. A lot of these formats come close, but some things you still have to complete it in your game engine. But this option does its best. So whatever material you have in Blender, try to export it. So then Godot will try to take them over. If your materials have images, meaning textures applied, it will also maintain them. Automatic in this case is Blender supports different image formats, so it will try to keep the original image format, or otherwise it's going to try to convert them all to JPEG. So these two options, you won't touch them most of the time. And this is a relatively new option. This is an advanced thing, but as most of you know, I'm guessing that like people here are using the principled shader in Blender. So this is respecting more of its properties. Again, this just makes it a bit closer to what you see here, or the exported result will be as close as what you see here. This is an important option. When you have modifiers applied, and I prefer it a lot actually. I don't like to model every single vertex. If you don't choose this, if you start with a cube and you have 10 modifiers applied, it will export it as just a bare bone like cube. So remember to apply this. The rest is by default on, because you want to export the UVs and normals so the textures can be mapped properly. And also vertex colors is important because maybe if we have time, I'll discuss some shader stuff. This is again important. These loose edges and points, sometimes I see in tutorials that while using Blender, people create just a vertex or just an edge. They are not part of the overall geometry. They are kind of, in a sense, like loose. They just sit there. So these two options are also maintaining loose structures. So when you export your files, it's going to be the file extension will be GLB, even though the file format is called GLTF. Again, for completeness sake, I'm going to expand this area, show you the options. So all three options will start with GLTF. The default one, binary, is what you should keep. This is compressing all the data. It's the smallest file size. This is when you have the definition file plus some, like in the bin file, you have some extra stuff, and the textures are a separate entity. So this is when you want to separate things. This is a really advanced case. You won't bother, and this is again, like, there's really no reason for you to choose this in case you feel confused, because I hear that well, you should use GLTF. Well, it's tempting to choose the last one because the file extension says GLTF, but really like GLB is just fine. So choose the binary option. And because I already have assets exported, I'm just going to hit cancel here. I actually usually tend to have the questions near the end of the presentation, but if you have questions up until this point, I'm happy to answer. If I feel like your question might be answered in the next few minutes, I'll say so and then skip it for that reason. I'm trying to see the chat screen. Let me pull it up. Well, it's possibly the wrong screen. Are there any questions? Maybe someone can tell me, because I'm having a hard time finding the chat screen.
No questions so far in the okay. Chats.
Good. Okay. Back to the slides. So we exported stuff. Now it's time to import. Let's go back to the agenda. This is the chapter 7 of the book, which actually covers the importing audio files as well, but I'm keeping it relevant to the group tonight. So let's worry about just the Blender parts, not the audio files. And for that, I think I'm going to have to. So I'm going to show my folder structure here. For chapter 7, I take the user. The user is, starts the chapter with the start folder, basically. And there are a few GLB assets exported from Blender. Windows users, I don't know if this exists in Mac, but Windows has a 3D viewer, which lets you preview GLB files. So this was a file in Blender and is exported. So you can actually see the wireframe structure too. So let's try to import this into Godot. By the way, the first time you launch Godot, let's also show that too. So there's going to be this goofy robot icon. If you launch it, this kind of like select a project, sort of like repository list. It doesn't look fancy. I must admit, other game engines have more fancy logos and such. This one is simple. So I'm going to create this folder, and this is how our project starts. So this is the engine itself. Sometimes I hear people, this has so many familiar looking features to Unity. I stopped using Unity a few years ago. I don't know if the interface has changed, but essentially most game engines will have a 3D viewport, which is indicated by this press 3D. You could also switch to 2D workflow. And this is something that doesn't exist in Unity. If you want to write your script, you usually use an external editor. Most people use Visual Studio or Visual Studio Code. So they write their C# code, they come back to Unity, hit the play button and play. Godot, on the other hand, has its own built-in script or text editor, which brings you all the documentation and such. So this takes you to the online docs, but the same online docs could also be reached here within the engine. So this is sort of a brief view of the engine, but let's say a few more words. Here's your file system. This is where we'll import our stuff. Or when we import it, you'll be able to track it here. This is your scene tree. We'll construct our scene by creating engine-specific structures. And when you click one of these structures, you'll be inspecting them for their properties here. So it's a very simple workflow. And into this project folder, I will now go and put some stuff. So this is the project that I just created. There's an icon PNG, which is also what you see here, and default environment, some resource file, again, not relevant, but this is sort of one-to-one view. So what you can do now is, let's pull this aside. I'm gonna try to find the other file here. So let's import these three files in here, and let's be organized and let's call them models. So now when we switch to Godot, you will see this progress pop-up, which is processing the files. Now, you see a lot more than 3 files that I copied and pasted, but what we should focus on is basically are these 3 files. These are the files that I pushed into this folder. If you remember that during the export options, like on that export options screen, I chose to include material. And these are the materials that were exported from Blender, and Godot separated them. And I'm just going to click one of them, and you can see the properties. This looks very similar to PBR shader or principled shader in Blender. Again, there is no 100% match, but it's close enough. I don't think it's called albedo in Blender. I forgot the name. I think it's just called color or base color. But all the other properties, you have them. The metallic, specular workflow, and roughness. You could either have normal map or a separate height map, which is labeled as depth. So some names are close enough. Again, you could read the documentation to find those differences. It supports multiple UV, which means that you could have your normal textures applied to your material, and for decals and other sort of overlaid material, you could use a separate UV. I think one thing that a game engine does for you on top of, or I don't want to say as opposed to, because I don't know 100%, but you could chain materials or shaders. So although this is a green material, I could be assigning another material, and that material will have its own next pass. So I could be kind of infinitely, as much as the memory allows me, I could be applying many other materials and chaining them. So that's where you get out of sort of a static Blender environment into more dynamic, changing game engine sort of workflow. This could be creating a lot of cool effects, but it could get quickly complicated too. So going back to our slides, at this point, you might be concerned about workflow. Maybe not in the first weeks, even months, if you are like learning Godot, but eventually you will find yourself in a position where like, okay, so I have models, which is GLB file like here, but I have a lot of materials here. It's going to be a nightmare to find your way around. So inside models, you could be having maybe a sconce folder. Could just drop the sconce GLB in that folder. Then that folder will only have that sconce models materials. But then what if we use the same material for different models in Blender? And maybe your workflow, you thought, well, you could be picking colors as labels for your materials. Like maybe for you, dark green means this, maybe light green is a lighter version of this green. That's why you will have kind of workflow considerations here. It's sort of impractical for me to show each case here. I did my best in the book, which was difficult enough, but here I'll kind of discuss, like instead of showing, I'll maybe tell you. So one way is labeling your Blender materials by purpose, meaning if it's a sword, maybe you just say, okay, this is the blade material, but there's also hilt. If you have different sort of like distinct sections of your model, you could label them by the purpose that like part of the model serves. That's one way, which then may lead to duplication because, well, what if the steel sort of gray specular, so like you prepared some material, what if another metallic surface has the same properties, but it's a completely different shape, it's a different design, maybe it's a bucket. That's when you will have duplicate materials, properties-wise, with separate names. So the steel, sword steel will be the same as bucket, but then it will be exported as two different materials. One way to prevent that is to go by color. By color, I mean the hexadecimal color or the RGBA color, so that you know your albedo is always like a distinct green color or red color, and maybe you create variations of that. So you come up with a naming structure. It's some hexadecimal code dash, maybe you will have 2 or 3 numbers that indicate the metallic specular roughness value, that sort of thing. So that may be a solution. Also, separating your, importing your models into separate folders might be a useful thing. This might be actually enhanced like a step further. If you find yourself like having a lot of folders here, but dark green is, if it exists in multiple folders, maybe you will want to extract it to a higher level folder, and then a lot of these models will be sharing that. So again, that's something that maybe you will be concerned about later on. It's not something maybe most beginners will worry about. The only problem is in your, like the overwriting might be the problem here. That's why I'm talking about this, because in Blender, if you choose dark green for 2 different models, But in one model, really the color code of that dark green material is different. So then which dark green is going to be exported? One will overwrite the other one. So that's when you may want to separate into folders or come up with a smart naming convention. Staging array is another flavor of this. This is if like someone just bets what is coming in, what is coming out, and there's a person separating this accordingly. It could be you. So we just saw the importing materials, but let me see. We're not going to make a scene yet. So importing animations. So we have sconce, which is a static model. Vessel is, if I recall, this was just a simple receptacle, something like this. Yeah. Neither the sconce nor this vessel, they don't have animations, but I think snake does. This snake has this idle animation. Okay, animation 1, animation 2. In animation, okay, so this is the idle one, and this is the attack one. I think sometimes Windows loses the label and does a reverse order. About this, what I have to say is, I may not have that file here. So in Blender, this is something that I can show. When you create your animations, I don't have any here. But you could label your actions. There's a way to label your actions. Please do so, because otherwise you will have some like bizarre names. I think Blender by default puts it like new action 1, new action 2. Those won't be helping you. So on that note, it's actually very typical to start with a cube and just, have it, and then you just keep creating. But things here will always look like cubes, spheres, they're sort of like a basic geometry name. When you export your stuff, it will be super important to label at least the highest level, so you can find them easily in Godot. Otherwise, when you import them into your scene here, you will actually see cube, cylinder, and a lot of weird names, and you won't find your way around. So let's make a scene out of sconce. And this is a way to create a scene. So we just said, you double click the GLB file here in the file system, and you have the item here displayed. As you can see, this must have been the origin point in Blender, so it actually understands and puts it in the world center. That's why I was emphasizing the origin point. So maybe it makes sense to put the origin point here or here if this thing is gonna lean forward and, I don't know, like break off the wall, that kind of thing. Depends on your use case. This sconce is in Blender. I think I have that file. Maybe I can open that. There you go. So this is the collection. It doesn't have a name, but when we exported it, that's where you can kind of get away with some like naming conventions. We exported sconce because it had two basic structures here. It carried these structures over to Godot. So you have base and flame, and you have the base and flame imported here. That's when that scene tree in Blender and the naming convention, it's not a hard rule to name every single thing, but if it's going to help you, do so. So, so these two structures are mesh instances as they are named in Godot. which is assigned a mesh. So this is your geometry in Blender. And when we click, so you see some details, and I'm expanding the surface. Sometimes meshes are complicated. It may have multiple surfaces, but in this case, this is a kind of a like just one simple structure. This is similar to having a geometry in Blender, and you will choose certain faces and assign a material, and some other faces of that same object will have a different material. This is the same idea. You could have multiple surfaces in that sense, and each surface will have its own material. This is basically one-to-one. And here is the material properties. Here, this material preview is kind of shoved into this area. But if you want to analyze this by itself, this is coming from Models Fire material. You could double click, and then the whole inspector will be populated with that material's properties. It may be helpful sometimes because sometimes this list may grow too long. But the changes that you'll be making here is as if you individually open the material in the inspector. And here's where naming conventions or the export options might be crucial. If you decide to have a different color for the base, or maybe a different flame color. So what are your options? So you can do some of these changes in Godot, but if it's drastic changes, especially if the mesh is changing, you will have to go back to Blender because you won't be able to edit vertex information in Godot. There are ways to do that, but it's painful. And chances are if someone changes it here, your team member will go back to Blender one day, they will do something without knowing that you have updated it here, or that person may very well be you. So keep things like that, maintain one source of truth. So go and change it in Blender and then kind of repeat and like rinse and repeat. When you overwrite the GLB file, the changes will be automatically picked up and reflected here. With a few sort of edge cases, if you are changing material references, if this flame was applied a fire material, but has a sort of like hot fire material because it looks more yellow than orange, then this fire material won't be deleted from Godot, but a new hot fire material will be put next to it. So to keep this area clean, like I said, some of these practices, it's something that you have to figure out. It's about your workflow. So this is essentially how you make a scene. And when you make enough of these scenes and put them together, you could design a level, which is our next slide. So here is an example of a floor piece. This is similar to how I constructed a sconce. So double clicking the GLB file, this is its own scene. And then I'm actually going to open some of these. Don't worry, I'm just kind of showing the bulk of the workflow. You could compose scenes in other scenes. So here we have a scene that is composing two scenes that actually are the floor tiles. So if you put enough floor tiles and a few other structures that are vertical, maybe some props, then sooner or later you will have this level. However, in this case, something is missing, which is this last picture here, the body of water. How do you export water from Blender? You kind of don't, because there is no such thing as water model in Blender either. That is usually done by shaders. So it's usually a plane subdivided, and you end up moving the vertices of that plane up and down. There's some noise pattern. So that's exactly what you do in Godot 2. You write a custom shader to change a plane so that it actually looks like water. You have a few exceptions like that, not exceptions, but sort of like you cannot directly import from Blender because it's not something you could export. It doesn't make much sense. But otherwise, do your stuff in Blender. Make sure you have no angles. Origin point is set correctly. The scale and rotation is applied. Export to GLB. Double click, create a scene, create bigger scenes. Let's say water is extra. Maybe you don't want to have water. So what is actually missing here is, well, it looks gray. So this is a Blender render, if possible. If like we could make our scene look more like this, and it is actually possible to do so. Although we imported a sconce model, we could, and we also have candle models. They are just vertices, so we still have to create our own lighting system in Godot, and that is also possible. I'll actually look into these files very soon. I just want to finish these sort of the slides. So here we have the candle model itself, but we are also putting a light object in the game engine. So this is called OmniLight, which is the equivalent of point light in Blender. Blender has sunlight, which is called directional light in Godot. There is no such thing as area light. And there's one more light type, spotlight. I think there is one-to-one called spotlight. That's the only one I think that has the same name. So the reason why I sometimes insist on creating individual scenes for models, and this is not something you have to do for every single model, but you will often find yourself in a situation like this. If I'm going to have multiple candles distributed around my level, instead of pushing individual models around the scene, if I have a candle scene which has a light object, if I create instances of that candle object, then each candle will bring its own light object. So that will save me from moving one candle model here, positioning a light object, and doing that for every single one. So they are going to be self-contained units. And these two are somewhat advanced. I'm looking at my time. I'll just say a word about this. Maybe if we have time, I'll show it. So when you enable the lights, you can change the, like you can apply post-processing effects, which will turn this still gray looking and somewhat like lit screen to this like, okay, this is kind of like a cave environment. We will have dark spots and even darker spots. And finally, apply global illumination. I hope the difference, the benefit is coming across. So this is an image split here in the middle. So the left one is without global illumination. So there is a crate here, and shadow is cast on this wall here, and there's the like half of a door, arch door here. It's hard to see. When you turn on global illumination, you see some part of the door. At least this arch is more pronounced, and the shadows are more soft and more believable. Like here. This area is closer to the light source. This area is like there's more distance. It makes sense to have a darker spot here than here. You lose that nuance on the left side. So global illumination is essentially, this is your step towards simulating what you maybe create in Blender. So there are ways to have a prototype in Blender and come closer and closer to what you were planning to build. So now I will try to go and open some of those steps. So in the book, the creating level is chapter 9, which is essentially a blank canvas, and we have models, and these are all the models that the reader will use, and some textures. There's only one. So at the end of this chapter, this is where we end up with chapter 9 finish. Because it would take too long, I'm not showing every step, but this you see a finished result for each chapter. So creating scenes and composing scenes in other scenes. So I'm gonna expand, sorry, I'm gonna actually do collapse all here. I'm not sure if it did actually. Okay, I'll do it manually. Maybe my computer is taxed right now. So you could have a very big scene, but yeah, you could organize your way around. And this is what I said about the water shader. This is basically a plane with shader applied. I'm trying to find the material, most likely here. You could write your own code to create a shader. This is something that I ended up writing. There is no like water shader in Godot, but it's actually just 10 lines of code, which is using a noise pattern. And there's some parameters here. You choose the color and the height, which actually changes the oscillation. Everything else, as I said, is just objects distributed around. And after you finish this level building, chapter 9's finish basically becomes chapter 10's start. So you start there, you build on, and you enable lights and shadow. And this is where you end up with. So now, by this point, the global illumination, I believe, is enabled. It is here, in here. And you could also be maybe asking yourself this question, well, okay, we have the candles, sconces, but does that mean the lights will always be on? Well, it kind of is, but if you write a little bit of code, you could do something like, I'm trying to find where the sconce is. Let's select this. I prepared this object so that it actually has a property. I say, well, is this lit? Yes. And I say, well, turn it off then. So it goes off. You could do a few tricks like this. Now, this may seem like something that actually helps you while you are constructing the level, but this is kind of where you get into game development. Well, this thing that I'm doing to help myself build the level, what if I give my player a way to turn, on these lights? Maybe there's going to be some kind of like proximity. Maybe your game character will be approaching a certain spot with a torch in their hand. That's when you check a condition and say, okay, now it's time to turn on, and it will actually come to life. This is where you really transition from manually doing things in Blender because you use maybe animation timeline. That's still a manual approach. Here is you are now in the interactive realm. So that's what I might say between like, well, I'm going to be always working with models, shaders. In a sense, the workflow is different. The end result is different. Although Blender is quite exciting to use, working with a game engine always feels more dynamic than using Blender. So one is more static, the other one is more dynamic in terms of comparison. Because sometimes I get to hear questions like, well, aren't both doing the same thing? No, they are not. They are complementing each other in a sense. I'm just checking my time. I think now might be a good time for me to stop and get your questions, because I may decide to show up different parts based on your questions instead of taking that liberty. and maybe showing things that you may not be interested in. So go ahead.
Thanks for that. So lovely presentation. So
You're
first
welcome.
question I have is, where can we find your book?
The book is on Amazon, I think on all Amazons. So Canada, United States, and I think UK as well. So I did not actually link it, did I? Actually, maybe I linked it here. I linked it to the com.
Cool.
Yeah.
Would you be able to put that in the chat for us?
Sure. I think
if not, I can do it for you.
I think I'll change this to the UK address, and you have to find the chat screen.
Maybe if you stop sharing, it
Yeah,
appears.
is that the, okay? Or while I'm sharing, okay, I found the chat screen. There you go.
Thank you.
Good. You're welcome.
Yeah, thanks again for that. It was a lovely presentation. Yeah, I'm not sure if any other people have some questions for our speaker.
Yeah, actually, I've got one. I'm sorry, it's very specific to me, I think, probably. But it looks absolutely fascinating. And I have a specific possible need for it. No, need, maybe not, in that I'm doing a website on about one of the medieval wars in UK called the Wars of the Roses. And I want to create sort of battle scenes which are a bit more realistic than the normal things you get on a, you know, blocks of soldiers moving around. So it's not a game, but it's a kind of it would be I don't know what you call it, really, a demonstration or whatever.
Okay.
Do you think Godot would be appropriate? Oh, and the other thing is, if you do something in Godot, can you then convert that so that you can show it in a website? Or
Definitely.
Oh, great.
So Godot has HTML5 export. So if you're familiar with that technology, it's using WebGL. So
okay, yeah.
Yeah, you could export it to HTML5 in that sense. However, I don't know the scope of your project, but if you're using a lot of sort of explosions, like I don't know how.
No, it wouldn't be like a full simulation.
Yeah.
Just to
So
show,
it's about
over time how people moved around, really. That
yeah, it's about the limitations of like a web browser at that point. If you run it as a desktop application, then I guess the performance will go like, you know, will be better. But it is quite possible. In fact, I'll actually show you the export options instead of telling. So these are all the options you can use.
Okay.
So the HTML5 I mentioned, you could be doing the mobile formats.
Yeah.
Mac OS is possible, but you always need a Mac to export to Mac anyway. But I mean, regardless, you could export it. These two are Windows applications. So this is more like a sort of mobile app for Windows platform.
Okay.
I believe, I might be wrong, but I think that's what they intend to do with that. And of course, Linux. So it doesn't support consoles yet, and that's not a technical issue. That's a licensing issue.
Okay.
I think powers that be didn't really, or they don't give kind of permission to Godot to implement console export. They are just not legally able to do it.
Okay.
And most of the time, as a game developer, you have to meet either Xbox or Sony. Like you have to sit down and agree. Like they will be your publisher, so you have to come to an agreement, and they will send you a developer kit, and you have to be part of their program. So there's more legal stuff going on than just technically hitting a button. So I'm saying this because sometimes a lot of people see that the consoles are missing and they just dismiss this engine because like it's no good, it's not exporting to console. It's not because it can't, but it just kind of won't for legal reasons. Yeah.
Okay, thank you.
Yeah, you're welcome. And by the way, I'm really into Middle Ages stuff. So
Oh, great.
I'd be excited to see your work one day.
Well, eventually, maybe I get around to it if I'm still alive. Thanks.
You're welcome.
So are there any more questions?
I may just add one thing while maybe the questions are still being formulated. The programming language in Godot is basically this. It's called GDScript. I'm enlarging the font a bit. You could also use C#. It supports it. However, GDScript is easier to learn. It kind of resembles Python. There are sort of C influences. And the whole light switch is basically as short as this. We are just checking if it's false or not, and we are turning the visibility of a game object. This is a very simple case, but at least it's a taste for people to see what is involved in the programming.
Great.
Maybe a question. I'm also checking the chat. It looks quiet in case anyone's typing.
I think you've blown everybody away.
I see.
Here we go.
Is there a performance issue with the choice of language used? Is that the question you are seeing too?
Yeah.
Okay. I haven't tried C# long enough to answer the question properly. I'm guessing that question entails that whether we should use GDScript over C#. I heard from tests that C# runs faster in Godot. However, this is usually what's advised. Most of the time, if your programming involves simple things like this, maybe reading a file, which takes only a few lines to like read a file, take the content, and like make it available to your other game systems. Writing that kind of like C# code is quite painful. Because it's a different mindset. Like you create file streams and pointers. This, like, I'm exaggerating, but it takes a lot more effort to do simple things. That's where a game engine makes things easy for you. So for most ordinary things, use GDScript, but where you want to be really performant, maybe have like a AI layer where you will have a lot of computational things. Then you could also have C# in the same project. So these two scripts could run side by side. And they just talk to the behind the scenes sort of game engine structure. So we could be requesting in your GDScript code something that C# code is doing somewhere else, and they will just communicate with each other. So the performance issues then are going away. Because sometimes when people just look at the bulk numbers, like C# is super performant, let's just ditch GDScript. But what happened to developer experience? If it takes me like twice as long to write the same kind of code, I don't want that either, because, you know, production timelines, deadlines, whatever. It's possible to be strategic. I hope that answered your question. Because I think I may be answering a question. It may not be the answer you are seeking or satisfies you. I'm just trying to make sure.
Thanks for the presentation. I kind of got one question out of interest. I mean, I don't know Godot really at all. I did hear on the news recently that Godot, I believe it's removing, is it visual scripting
Yes.
from the engine? Is that a problem for you, or what are your thoughts on that? Because that kind of puts me off a little bit.
Not really. Well, for me, it's not a problem because I've been programming since early 2000s. I would much rather write code than visual scripting is like in Blender. We don't write code to create shaders. We use a node system. So it's convenient to drag and drop nodes to each other. So Visual Script in Godot is essentially the same. Writing code like that is okay for beginners. Maybe it's easy to visualize, but it becomes like very quickly like inconvenient, and like you have to look at a very large map of like what's going on here. And like if I'm going to find this variable, if I double click it, it's highlighted everywhere. I can just do copy, replace, sorry, like find and replace, add another condition here. It becomes very difficult to maintain after a while if you do the same thing with Visual Script. I don't think the node system in Blender grows so big that it's a problem. But any kind of visual like node system is, I believe deep down has the same problem. It's just that I don't think this is something most people notice in Blender, because the scope in the end is still limited. Like I don't think it's, maybe there is a Blender shader or like out there that actually has like 1,000 nodes, but I doubt that. But it could quickly grow to thousands of nodes in Godot.
Yeah, that's a good
so
point.
well, that's a workflow problem. The team that maintained Visual Script, they thought their effort would be spent better elsewhere. That's why they are dropping. So that's sort of
Right.
like a short answer.
Yeah,
Still let me know, I think.
thank you.
You're welcome.